So in this video we'll be looking at compound interest or depreciation or repeated percentage increase decrease. So compound interest or depreciation is also sometimes known as repeated percentage increase decrease. So this is when you have an initial amount or value and you repeatedly increase or decrease the amount by the same percentage over a duration of time. So this is where you have a starting amount and the percentage will either increase or decrease over a fixed period of time. And this is kind of commonly used in the real world with regards to car payments, bank accounts, house prices, and these are all very common themes that are related to this particular question. It's also, if any of you have got any interest in financial maths, it's a really good topic to kind of get you started and thinking about how interest rates work, what percentages mean, and when you've ever seen them on an advert, particularly for things like bank loans. And if you read the small print, it will literally tell you. And although these models aren't what you learn in lessons, isn't quite the same in reality, because obviously sometimes you can have fixed percentages and sometimes you can have variable percentages depending on what you're dealing with, but it's something to definitely get your teeth stuck in. Now with regards to the formula, now there is a particular formula that you need to be aware of, and it's important that you understand how this formula works. Now basically with regards to compound interest or compound depreciation of an amount, we have an original amount which is our starting value, and so just write down what that is. So this is our starting value. Now the decimal multiplier after the percentage increase decrease. So for example, remember that if you've watched the previous videos, that you're always starting with 100%, and then you're either going to add or subtract the percentage change. And because you want that as a decimal, you need to divide that by 100. And that will give you our decimal multiplier for this compound interest amount. And then the time can either be in years, it could also be in months. It could be, I think there's probably the most common ones, maybe weeks, maybe days, but it's definitely worth commenting on that. So for example, what we'll do now is we'll go through, so if I just go through some examples for this. So if you were looking at a 5% increase, then that would be 100% plus 5%, which gives us 105%, which as a decimal would be 1.05. Now, shouldn't really write the two equal signs on this because obviously these things aren't equal, it's just the equivalent. So it might be a case of just kind of approximating or just doing this. I'm just writing it just to save space. If I'm looking at a 70% decrease, then my decimal multiplier would be 100, take away 17, which is 83, and that as a decimal would be 0.83. So again, it's a case of making sure that you've got the right decimal multipliers based on whatever percentage you are increasing or decreasing. Now, if that makes absolutely no sense to you at all, hopefully it does when we go through some examples. So in our first example, we've got the value of a brand new car which is priced at 29995 and depreciate. So basically you need to sort of practice some of these keywords that are used in these maths questions. So this is our original amount. This means that it's a percentage decrease. This is our percentage amount, and these values here are our time period. So for this, what we need to do is work out this. So if I start with A, so our starting amount is 29995 times. Now with this, we're starting with 100% and we're decreasing by 18%, which leaves us with 82%. Now that as a decimal is 0.82. So here my decimal multiplier after the percentage decrease is going to be 0.82. Now the time for question A is 3. So what we're going to be doing is 2995 times 0.82 to the power of 3. Now if I plug that straight into my calculator, I'm going to get an answer of 16,538 pounds and 28 pence. Now remember that when you're dealing with money, always make sure you're rounding to two decimal places. You don't really need to quote two decimal places when you're dealing with money. It's kind of something that is implied. Now for B, I'm going to use the exact same sort of layout of the formula, but the only thing that changes in this particular question is the time period, which in this case is 6. So I'm going to type in 2995 times 0.82 to the power of 6, and that gives me a value of £9,118.68. Now again, if you're not sure about how to work out your power button, it's usually, depending on your calculator, it's either going to have a little arrow, or you might have a button that looks like this, or you might have a button that's got XY. Something along those lines will allow you to type that in, and all you do is, as soon as you've pressed the 2, press one of these 3 buttons and it will allow you to get your powers up. So for the last one, so for C, we're going to do 29995. You can see how the original amount never changes, times 0.82, nor does the decimal multiplier, and this time we're going to do 10. So this brand new car that was priced at just under £30,000 after 10 years is only going to be worth just over £4,000. And there you go. Now, where the marks are usually awarded for this particular question is you would definitely get a mark for using the right decimal multiplier. That's 1 mark. And then if they're being quite generous, they might give you a mark for the general sort of line of working out there, and obviously 1 mark for your final answer, making sure you've used the correct method of rounding up. So if we look at our next question, so this one's dealing with a bank loan. So a bank loan charges 4.6 interest per annum. Now again, in terms of the wording for these, per annum basically means per year. And with interest, this means a percentage increase. Because obviously that's one of the main reasons why people put money in the bank, not to keep it safe, but also try and earn some extra pennies or pounds from whatever they've deposited. So it says the total amount payable is 23,000. So for this is going to be our original amount, and these are our time values. So with regards to A, we're writing our original amount, which is 23,000. Now with this looking at percentage increase, so again 100 plus 4.6 is 104.6, and that as a decimal is 1.046. So we're going to times this by 1.046, and for the first part working at 8, our time is 8, sorry, so we've got 23,000 times 1.046 to the power of 8, and that gives us 32,959 and 55 pence to 2 dp. For B, again exactly the same, so 23,000 times 1.046, and this time we're going to do it over 15 years, so 23,000 times 1.046 to the power of 15, and that gives us 45,154 and 71 pence. So you can see, and basically what this basically means is that if you were borrowing money from a bank, so for part A you're borrowing 23 grand, the interest rate is 4.6, and over 8 years, so you'll be looking at giving the bank over the course of 8 years just under £10,000 over what you actually originally borrowed. If you borrowed it over 15 years, you're looking over £12,000 for just lending you that money. And again, for mortgages, it's quite scary. I would definitely look into that, but be glad that you're not that age where you need to worry about that. So for the final part for this particular question, we're looking at 23,000 times 1.046, and this time we're looking over 23 years. So 23,000 times 1.046 to the power of 23, and you can see there that after 23 years you are actually paying almost triple of what you actually borrowed, and that's the scary note of mortgages. So looking at our next example, so here we're looking at a mortgage, so an £185,000 mortgage is taken at a fixed rate of 3.45 over 30 years. Find the total repayments after 30 years. So for this, what we need to do is highlight the key bits of information. So with a mortgage, you're looking at owing, so it's about having a bit of common sense with regards to these. So this is a percentage increase. So it's not where your money is being taken off, not repaying anything. It's a case of the percentage increase. This here is our percentage, and this here is our time. So in terms of how working with this out, we're going to go straight into plugging this all into that formula. So we've got 185,000 times, now again to work out the percentage, we've got 100% plus 3.45%, which is 103.45. And again, you could do all of this in your head. You don't need to be writing this down, but I'm just doing it for illustrative purposes. So this here is our decimal multiplier. So we've got 1.0345, and we're going to work it over 30 years. So 185,000 times 1.0345, and we do that to the power of 30 years, in which it's going to be 511,783 and 85 pence. So to put into context, the average price of a house at this moment in time when I'm making this video is about 240,000 pounds to purchase a house. Deposit wise, you're probably looking at 10% at the very least, so you could take off about £24,000 off that, leaving you with about £216. That interest rate that's quoted is probably a little bit high at the moment, which is probably looking at about 2% at the moment, and 30 years is probably the expected time. So if you're wanting to buy a house, and most people aren't fortunate enough to be able to pay a house out cash, most often 99% of people always have to take out a mortgage. So a 30-year mortgage is probably about right. So in terms of a bank, you can see there that by borrowing £185,000 over the course of 30 years, you're actually going to be paying £500,000 just to pay in terms of that mortgage over 30 years. So it's definitely worth looking into with regards to whenever you come to that position where you are looking at buying a house and making sure you get the best rate possible. Now for the challenge question, we've got a brand new car, its new value is £34,995, which depreciates at a rate of 24.2% per annum. After how many years would the car be worth less than £4,000? So at your age, you probably got your eyes beating upon your future car in terms of that, and also looking at depreciation rates. Now it's really interesting actually when you're looking at all these flashy cars and of what the actual rate at which their value decreases, because obviously as soon as you drive your car off the parking lot, it's lost money already, because automatically it becomes second hand, and no one wants to pay a full price, brand new price on something that's second hand. Now again, per annum means per year. So this car is losing a quarter of its value every year, and we want to work out when is the car going to be worth £4,000. Now for this particular question, at KS3 or at GCSE level, there is one way of doing it. If you're looking at A level, or depending on how sort of methods you've been taught in class, there is a way you can work it out, which is using things like logs. Now log is probably something that you could see on your calculator. Never really wondered what it actually does. Well, it kind of works for these types of questions. So in this, what we want to do is we've got our original amount, which is 34,995, times, now we're looking at a percentage decrease, so we're just going to make a little side note. So 100 take away 24.2 is going to give me 75.8, which as a decimal is 0.758. So I'm looking at 0.758. Now I don't know what that power is going to be, and I'm looking for where the value is going to be less than £4,000. Now as I mentioned, there is a way of you working this out without having to do any sort of guessing, but unfortunately at this level it is all about guessing. So what you kind of need to do is using the format of 34995 times 0.758, and what you need to do is just simply plug and guess numbers of the power. So guess the power, and what we want is we want to find the number that gives us our first value under 4,000. So for example, so 34995 times 0.758 to the power of, now if we just start off with, let's say 4, so if I just call this x, so when x equals 4, then the value is going to be 11,552.68 pence. So I'm definitely way off. So let's have a look at x equals 7. So if we change that 4 to a 7, I get 5,000. Definitely getting closer. 0.42 pence. So let's try the next one of 8 years. And in the sort of test or an exam, what they're looking for is you having several attempts. Now, you don't want to be getting straight to the answer straight away. They are looking for sort of guessing and the fact that you're working towards a number. So here you can see when I try 8, I'm getting 8 years. I've got 3,813.81. What should be two decimal places. So as you can see now, because I've gone from 7 to 8, I know that when it's 7 years, it's over 4,000. But when it's 8 years old, that's going to be my first year of where it's going to be under £4,000. So if I went to, let's say, tried x equals 10 years, then obviously I'm going to get a value that is less than £4,000. But is it the first year? The question's asking after what year is the car going to be worth less. So although after 10 years it is worth less than £4,000, it's not the first year that it's worth less than £4,000. So your answer is 8 years. And again, it's always worth emphasising what your final answer is, particularly like what I've got on the screen here, where your numbers are all over the place.